Okay, we are recording here. I'm going to do a quick review or preview of user coordinate systems for you, how I prefer that you define them, and most especially how they are then stored within AutoCAD. This is in response or in connection to learning how to deal with the unit vector, which is a vector in the unit vectors, I being the unit vector in the X, Y being the unit vector in the Y. I'm sorry, I being the unit vector in the X, J being a unit vector in the Y, and K being a unit vector in the Z. Of course, those directions are only as assumed in the coordinate system. Those are fixed to some known coordinate system. In AutoCAD, you may have a great number of coordinate systems. We also were introduced to lambda, which is the unit vector in the direction of the vector, or more or less a one unit piece that's going along the direction of the vector that you are dealing with. What we're going to do here is we're going to look at a Rolodex that we'll play with a little bit through class as I give each of you a card on here. Cards are all different colors, and we'll change them and do all kinds of different things with them. But for now, I'm just going to go and show you what the Rolodex looks like by first and foremost typing in plan, P-L-A-N. I'm turning on my on and off my keyboard here because this thing needs to somehow boot up. This is a wireless keyboard. I am recording this on an iMac, Mac OS 10. About a 2 gigahertz processor, 2 megahertz processor. Hopefully it should be on now. And we want to see that there's different ways to go to the plan view, but that's a great one to always be able to hit because it puts you in looking straight down on a coordinate system. Now, the coordinate system I'm in can be kept track of right here in the toolbar, which is the UCS2 toolbar. That, of course, would be followed along with the UCS1 toolbar. So I'll put those out here, though I may be speaking a lot of these commands as well. Now, along with learning to use dview, one can also learn to very quickly kind of get a general sense how to use vector and camera stuff by just keying in using the command vPoint a location from where you want to look down at the 0, 0. So you can, and you will continue to use and start to use this wheel, which is a great thing. Orbit there, I can kind of pull around like this, right? And I can kind of get it where I want it about to be, my view. Right? I'm going to wheel out here. Escape, 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 Z space, E space. And we were learning to use views a little bit, so right now I could type V for view. I could say, and you're right here, it shows me this information about what I'm looking at. I can say new here. I can just put funky view, right? Because I really arbitrarily set up where I want to be. Turn off saves layer snapshot with view, current display. That all looks good. Hit. You're not seeing all this, but I'm clicking on all that stuff, and I'm clicking OK down here at the bottom. Apply, OK. If I want to get back to, I have changed where my camera is, but I haven't changed my coordinate system here. So if I want to get back to looking straight down at my coordinate system, I type plan. I'm going to go into my current, or the world. This is my current coordinate system. I'm back here, I believe, to the world coordinate system. So another way to look at it instead of using dview is to use vPoint. Typing in vPoint and then give it a direction, 1, 1, 1. I am now looking at from 1 in the X, 1 in the Y, and 1 in the Z. I'll make a view of this by typing V, spacebar. Again, it's setting a bunch of information here. I can say new, I can say funky 2. Always turning off the clicky clicks. I'm hitting OK, hitting apply, and OK. And obviously you have and will continue to use views in a great number of ways. Now what I've got here essentially is a three-dimensional Rolodex that's stored, if you would, or encased in a extruded set of circles, right? That's a solid, and these are each 3D faces, and you've probably looked at these a little bit in the past. You look at them again in the future, there's a difference between a 3D face and a 3D solid, especially in AutoCAD 10. And again, as I talk about AutoCAD 10, a lot of this stuff segues over into all the other products they've got. So I'm going to go ahead and learn a little bit different ways to draft. I'm going to click on that, hit a right click, look at properties. It's telling me this is on the centerline layer. I don't know why it's on the centerline layer. I'm going to change that down to the object layer. An object layer, you just saw, had been frozen. I now have a bunch of Rolodex pieces of paper, if you would. And now what I want to do here, I want to go through and define a coordinate system for this face. Now I'm going to point out that you can do a coordinate system using UCS by grabbing an object, and I'll do that first. However, what you want to do, you really want to get used to doing a 3-point coordinate system. In Simple 3D, you won't have to do this anywhere near as often as you will in other products, but getting a hold of how coordinate systems work in terms of being a translation and 3 rotations is an important thing. You can usually do that by knowing 3 points, and that's what you will have done in Wolfpack, and we'll kind of review that. So I'm going to do, first and foremost, I'll do a UCS, and here is your regular UCS toolbar. Each of these is tied to something, a face UCS, an object UCS. And it's interesting, even though I'm dealing with 3D faces here, it won't let me use the face UCS. So I'm going to just try to do the object and see how it does. So I'm going to say UCS, object. I'll click on that. And I'm going to select an object to align it with. Right there. Now, the problem when I did that is it's the 0, 0 isn't necessarily where I want it to be. So if I draw a line now, from 0, 0, it's going to be in the new coordinate system. And you see it kind of picked some arbitrary spot. Let's say I wanted that user coordinate system to start right here. That was to be my origin. And I wanted to have this is positive x and this is positive y. The way to do that is with a 3-point UCS. The way that I typically key in, so I don't have to deal with all the toolbars around, is UCS, new, 3-point. And it's again getting you used to what you're doing in terms of vector mathematics, which is drawing the x vector, drawing the y vector, and then doing a cross product to get the z. That said, you can always go back to world here, using my toolbar here, UCS, world. I'm back to the world user coordinate system. I'll try it again using the clickies, using a new coordinate system using 3-point. And now I'm going to be very good. Shift right click the end point of that. Shift right click near, and this is kind of crowded, but hopefully I can get the very edge there. For the positive x, shift right click near. And these things are falling off your screen, but you should be just listening as I'm snapping. And you see now it will have changed the coordinate system so that if I draw a line from 0, 0, 0, it's originating from there, and it's actually, if I 0, 0, 0 to 0.5, 0.5, 0.5, I'm sorry, to 0.5, 0.5, 0.5, it will have drafted something up based on this coordinate system. When you make a coordinate system, it's a really good idea to save it if it's as import. And there they are, a name coordinate system. I'm going to type this and we'll check later how you go about doing it. You see I've got a bunch of these already defined. Those are all my coordinate systems. Coordinate systems are not views, that you can align coordinate systems with views. I am going to say now UCS, save, and I'm going to call this gray. I'm sorry, white 1. I'm going to replace it. I already had it done. So now I've got it. The last, final, and key thing to do when you're dealing with user coordinate systems, until you really know what's going on, is to, once you've made the coordinate system, type in plan. Believe it or not, try this